According to the 2020 Global Forest Resources Assessment, the world's forests span 4.06 billion hectares, accounting for 31% of the world's land area. About 45% consist of tropical forests, followed by boreal, temperate, and subtropical forests. However, forest destruction by humankind is still ongoing, and 178 million hectares of forests have already been destroyed after the 1990s. Fortunately, the destruction rate is slowing down. It has decreased from 7.8 million hectares in the 1990s to 5.2 and 4.7 million hectares in the 2000s and 2010s, respectively. The reduction in forest destruction rate is due to the increase of forest area in Europe and Asia, especially in China. In contrast, forest destruction in Africa and South America is still rapidly increasing. Especially in Africa, forest destruction continuously increased over the past 30 years. Forests are some of the most diverse ecosystems on our planet. Forests are home to over 80% of terrestrial biodiversity. Among forests, the tropics have the most remarkable biodiversity on the planet. While tropical forests comprise only 6% of the world's surface area, they contain 1/2 to 3/4 of the Earth's species of plants and animals. Therefore, deforestation of tropical forests could lead to the loss of as many as 100 species a day. With more than 1 billion people directly dependent on forests for fuel, housing, and nourishment, the fate of our forests may determine our future as well. Connections between forests, human health, and biodiversity are firm. These connections include essential ecosystem services to human survival. Healthy forests with extensive root systems absorb water and bind the soil of sloping land to reduce flooding and prevent catastrophic landslides. Moreover, plant biomass reduces evaporation, while aquatic plants filter and purify water. Climate change, or global warming, is the biggest threat that humankind is facing. The increase in greenhouse gas emissions, GHG, in the atmosphere is the reason for this. GHG includes about 16% methane, 6% nitroxide, 2% various fluorinated gases, and 77% carbon dioxide. 65% of the carbon dioxide emissions are from fossil fuel use and industrial processes, while the remaining 11% is from forest destruction and land cover change. Generally, forests act as carbon sinks that absorb carbon dioxide in the atmosphere through photosynthesis. Therefore, there is an increasing importance of using forests to mitigate climate change. However, forests and forestry are also affected by increasing GHGs in the atmosphere. First, increased carbon dioxide causes the carbon dioxide fertilization effect. It's the enhancement of photosynthesis due to the high CO2 partial pressure gap between the atmosphere and the intercellular space of plant cells. In short, increase in GHG also has a positive effect on forest productivity and efficiency. Initially, in experiments using controlled chambers, the CO2 fertilization effect reached up to 80%. However, the fertilization effect decreases in CO2-free air, where the conditions are similar to the existing ecosystem. When long-term research results were summarized, an average net primary production (NPP) increase of 23% occurs in response to the doubling of CO2 concentration in young tree stands, with the range 0 to 35%. However, many studies present that this CO2-induced growth is hampered by species, competition, disturbance, air pollutants, and nutrient limitations. Elevated CO2 in the atmosphere also affects temperature and precipitation patterns. This consequently affects tree migration. Tree species naturally migrate towards more favorable environments. The migration rates of tree species have risen dramatically from less than a few kilometers per decade in the last glacial period to possibly 50 kilometers per decade at the climate zones in the future. When CO2 concentration reaches double the pre-industrial level, the increased temperature and growing seasons project a poleward migration of vegetation by 500 kilometers or more toward boreal zones. Many models predict forest migration and replacement of up to 50% towards the tundra area. However, there is also a worry that the natural forest migration is not fast enough, and that this may lead to a massive loss of trees at the southern boundary of the boreal forests, with a corresponding enormous carbon loss to the atmosphere. Also, climate change may modify the frequency and intensity of forest wildfires, outbreaks of insects and pathogens, extreme events such as high winds and droughts. These indirect effects could be more important and more devastating than the direct impact of higher temperatures and elevated CO2. Forest fires have dramatically increased, especially in Canada, the Western United States, and Russia during the last 3 decades. Climatic conditions caused earlier snowmelt, causing an extended fire season. This also increased the frequency and intensity of droughts, thus affecting fuel conditions, ignition sources, and fire protection policies. In addition, forest fires result in the loss of timber, pulp, and paper production, damage to forest health, and non-timber forest products. Forest health is especially of great risk with pest and disease outbreaks. Effects may include defoliation, growth loss, timber damage, and massive forest diebacks. Climate change can dramatically shift the current boundaries of insects and pathogens and modify tree physiology and tree defense mechanisms. The annual average forest area damaged by insects in North America is 2.9%. Another growing concern regarding insect migration is that they may damage trees that are presently intolerant to them. For example, warmer temperatures have already moved the habitats of the mountain pine beetle. The mountain pine beetle could seriously threaten the Rocky Mountain whitebark pines, essential for many wildlife species. While precipitation changes have affected that of the gypsy moth. The change in frequency of climate extremes, like heavy winds and droughts, can bring massive losses to forests. Harsh wind, snow, and ice can directly damage trees, while indirectly affecting early thaws on logging, reducing access to forest land, and increasing costs for road and facility maintenance. High wind, such as thunderstorms, typhoons, and tornado events, can damage fast-growing, lower-density trees in warmer climate regions. Damages include branch breaking, crown loss, trunk breakage, or complete stand destruction. In addition, extreme events can occur in a number of regions worldwide. Therefore, a warmer and drier regional climate may cause even more extensive forest damage. For example, the notorious heat wave in 2003 Europe led to an extreme forest fire season, which resulted in a 5.6% loss of the total forest area in Portugal. Extreme events, including forest fires, insect outbreaks, and wind damage, result in substantial economic loss. For instance, 8,500 California forest fires in 2018 cost $102.6 billion, roughly 0.5% of the U.S.'s annual GDP, while capital losses and health costs within California totaled $59.9 billion. Indirect losses through economic disruption to 80 industry sectors within the state came to $42.7 billion. Other related effects of more frequent extreme events under climate change include biodiversity loss, reduction in non-timber forest products, increase in erosion, and loss of aesthetic and recreational values. In addition, there are direct and indirect risks on timber supplies, market prices, and insurance cost. Because of warmer and longer growing seasons and the CO2 fertilization effect, various forest yield models project the increase of global timber production. An increase in timber supply will affect the market, generally lowering prices. However, the rise in demand for timber has been slow. As the Food and Agriculture Organization and models of the global forest sector predicted, global fuel wood use has already peaked at 1.9 billion cubic meters and is stable or even declining. With the share of charcoal continuing to increase, as fuel wood is converted to charcoal, the lower price of timber will enhance the use of various woody biomass energy. The use of wood for fuel and biomass energy could dramatically escalate with the rising energy prices and new technologies, particularly as incentives for fossil fuel is transferred to biofuels, which are viewed as recycling the emitted carbon. Some model-based estimates project an increase in biofuel demand during the next 50 years by as much as 10 times. Biofuels, particularly ethanol from grains and other plant materials like sugarcane, has already become an important source of non-conventional transport energy. Biofuels derived from woody cellulosic biomass made wood an alternative energy source. Wood cellulose is used in gasification processes, such as an integrated gasification combined cycle process, to produce synthetic gases, including hydrogen. These gases can be further used to produce energy directly or as feedstock to produce a variety of energy products, including not only ethanol, but also biocrude. In line with global efforts to mitigate climate change, the Republic of Korea enacted the Framework Act on Low-Carbon Green Growth in 2010, integrating climate change, global warming, and sustainable development measures to achieve low-carbon green growth. Accordingly, the first, second, and third national climate change adaptation plans were developed in 2010, 2015, and 2020. The third plan aimed to implement a climate-safe nation with the people, based on scientific evidence and participation of various parties. It recommended 232 tasks to be implemented by the Korean government to enhance the adaptive capacity to 84 climate risks by 2025. In addition, 41 representative public-oriented tasks in 8 sectors, including forest disaster, drought, and flooding, were selected through expert forums, Working Council on Climate Change Adaptation, adaptation governance forums, online public hearings, and discussion on preparing public-oriented countermeasures. In 2022, Korea Forest Service announced the 2050 Carbon Neutral Forest Sector Promotion Strategy, which includes major policies in the forest sector to respond to the climate crisis and achieve national carbon neutrality goals. The 2050 Carbon Neutral Forest Sector Promotion Strategy presents 4 key tasks: expansion of new carbon absorber forests, enhancement of forest carbon uptake capacity, vitalization of wood and forest biomass use, restoration and conservation of carbon uptake sources. First, new forests will be expanded by creating forests on idle land or increasing urban forests. New carbon sinks will be expanded through North Korean forest restoration and international forest cooperation. Second, the forest circulation management will be activated around the economic forest complex and timber production forest. The carbon uptake function of the forest is strengthened by the production of seeds and seedlings that comprehensively consider carbon absorption capacity and ecosystem impact. Third, the use of domestic wood will be increased for carbon storage and replacement effects. Forest biomass, a renewable energy source, gradually establishes a small and distributed supply system. Fourth, it will expand forest protection areas and promote restoration projects to preserve carbon absorption sources and minimize disaster damage, such as forest fires, landslides, and pest outbreak, to reduce carbon emissions. Through this, it is expected that 23.6 million tons of CO2 uptake will be contributed to the 2050 national carbon neutrality goal in the forest sector, and 3 million tons of forest biomass will be used in the energy sector.